Hello everyone, my name is Lalita. I am from CSC department and my XC topic is automatic accident prevention by smart traffic control. The purpose of this study is to design an automatic accident prevention by smart traffic control system using Arduino. The system incorporates the concept of managing or controlling road traffic and providing an emergency way for ambulance. This design helps in reducing traffic by continuously switching to red light or green light where the road with high traffic is led to clear first. This concept mainly focuses on vehicle traffic but not on traffic lights timer. The objectives of the project are the system prioritizes between the vehicular and pedestrian traffic by giving equal chances of using the road in times of continuous flows, and it prevents accidents. And the major objective of this research is to manage and prioritize a smooth flow of the road users and vehicles without causing any accidents. And the components which we have used in the project are mainly hardware components and the software components. And the hardware components which we have used are Arduino UNO, power supply, LED lights, breadboard, servo motor. And the software components are Embedded C and Arduino IDE. Let us discuss deeply about these hardware components. And the adapter which we have used is of AC to DC type. It means we are converting AC to DC voltage. It means the input is of AC type and the output is of DC type. And the output which we get is 12 volts and 1 ampere. And the servo motors which we have used is 4.8 volts, and it is of metal material, and the weight of the servo motor which we have used is 50 grams, and the torque is 1.8 kg centimeter, and the weight is 9 grams. And the LEDs which we have used are red and green, and the depth of the LEDs are 5 mm, and the height is 37 mm, and the width is 5 mm. And for connecting these connections, it means from Arduino to servo motors, and from servo motors to LED lights, we have used jumper wires. And for we have used for emergency purposes, we have used RFID tag. For this RFID tag, we have used RFID reader module, and its operating voltage is 4.5 volts to 5.5 volts, and the current consumption is 50 milliamperes, and it can operate on low power, and the operating temperature is from 0 degrees Celsius to 80 degrees Celsius, and the operating frequency is 125 kilohertz, and it is of communication parameter which is of 96 bps, and the reading distance is 10 centimeters. It means the reader which we have used in our prototype is up to only 10 centimeters only, but in real time estimation it will be very high, and it will depend mainly on the tag which we have used. And we have also used the integrated antenna. And the features of Arduino. And Arduino, it is also known as Atmega 328P. It means in this Arduino we have used Atmega 328P microcontroller, and it consists of 5 volts operating voltage, and the input voltage which we have given is 7 to 12 volts, and there will be 14 digital input pins, and there will be 6 analog input pins, and the DC current which we will give is 40 milliamperes, and the flash memory of this Arduino is 32 kilobytes, and the RAM is 2 kilobytes, and PROM is 1 kilobyte, and the clock speed which the Arduino contained is 60 megahertz. And we are also using USB cable for connecting. It means for dumping the code from laptop to Arduino. For this we are using USB cable, and all these are the hardware components which we have used. And now let us discuss about the software components. And the software components which we have used are Embedded C and Arduino IDE. And the Embedded C is a set of language extensions for the C language that makes it more suitable for embedded applications. It means the language which we have used in our prototype is C language, and it means C language only, but the extension of C language. Mainly for the hardware projects, we will mainly use this embedded C. It means by this we will have more application for our project, and we can also implement new features for our project. So we are using embedded C. And the next thing which we have used in our software components is Arduino IDE. IDE means Integrated Development Environment. The Arduino Integrated Development Environment contains a text editor for writing code and a message area and a text console, a toolbar with buttons for common functions and a series of menus. It connects to the Arduino hardware to upload programs and communicate with them. It means for dumping the code to the Arduino, we must use Arduino IDE. And let us see the block diagram of our project. It is the block diagram of our project. In this block diagram, we can see that all the servo motors which we are using, it means the 6 servo motors are connected to the Arduino, and the 6 LEDs which we have using, that is red and green LEDs which we are using, are also connected to the Arduino. The circuit diagram, what we have shown in the block diagram is only shown in the circuit diagram. It means, see here we can see the Arduino. From the Arduino only we are giving connections to the servo motors, and from Arduino only we are giving input to the LED lights, and all the negative terminal of the LED lights are grounded. It means from they are series and they are grounded. And here in servo motors also, all the positive terminals are taken as supply, and the negative terminals are taken as the ground. And let us discuss about the working of a project. And here in our project, Arduino is responsible for complete functioning of this design. It means without Arduino, we cannot do anything in our project. It means Arduino is like a heart in our project. When the kit is provided with power supply, the Arduino goes on and the design is ready to function. When the red light glows, the barricade closes, and when the green light glows, the barricade opens. When the barricade opens, it means that we can cross the road, and vice versa. It means when the barricade open, only the pedestrians who are using the road can cross the road, and the vehicles who are using the road can also cross the road. And the next component is RFID control ambulance. In our project, the main implementation is, in the case of any emergency, if the barricade closes, the ambulance cannot go. So in that emergency situations, we are using this RFID control ambulance. The basic idea behind the proposed system is, if the ambulance halts on the way due to the traffic signal, the RFID installed at the traffic signal tracks the RFID tagged ambulance and sends the data to the cloud. By tracking this data, the cloud, it means it can initialize that the ambulance is coming in the way. So the gate, it means the red signal gets turns into green, and the gate will get open. It means the barricade opens and the ambulance can go in their way. And the benefits of this project is, and higher traffic safety, and it can reduce the number of accidents, and the ability to deeply manage the urban traffic, reducing urban traffic jamming. Due to emergency switching mechanism, this system is useful even in emergency situations. So there are many benefits by this project. And the real-time estimation is, in real-time estimation, another set of traffic lights are used for the pedestrian side. Instead of servo motors, in the real-time estimation purpose, we are using the gate servo motors. And the gate servo motors which we have used is of power, the rated power for that gate servo motors is 1500 watts, and weight is 30 kilocentimeter. And the rated torque is 7.16 nanometer, and the peak torque is 19 nanometer. And the rated speed is 2000 RPM. And the input voltage is 230 volts, and the AC is used, and the iron bars are 15 kgs. And the weights are used as barricades. Arduino UNO also used in our project. In real-time estimation, the gate servo motor will cost for 1,02,000, and the iron barricades will cost for 1,500. Arduino with 650, RFID reader with 50,000 cost, and the total cost for this project will be up to 1,54,150 rupees. And the conclusion of this project is, a successful designing and implementation of the system has been done, outcomes weighted against the theoretical objectives, and the satisfactory results were obtained. However, the intelligent zebra crossing has been a success to the road users, since pedestrian safety and confidence of on using the design designated crossings. So by this we can say that our project is very helpful, and in our project the main objectives are the system will mainly prioritize between the vehicular and pedestrian traffic by giving equal chances of using the road in times of continuous flow, and it also prevents the accidents. And the major objective of this research is to manage and prioritize a smooth flow of the road users and vehicles without causing any accidents. So by this we can say our project has more applications and we can reduce many accidents by this. So the implementation will bring us many advantages. So thank you for giving me this opportunity.